The subject matter of stats, this wonderful branch of mathematics, and some definitions. A datum is a single quantity, right? So a datum, you might have seen the word that often because you normally see data, which is the plural. Datum is the singular, data is the plural. And we represent them with what we call random variables. And what's a random variable? It's basically a function determined by the probability of the event happening. Random variables can be numeric. We like those ones because we can do calculations, but they could be categorical as well, eye colour, whatever. Random variables are continuous if the range of this function is an infinite set of real numbers. It consists of intervals. It'll be discrete if it's what we call countable. So it consists of individual values. Eye colour, I guess, would be discrete. You can't have half a blue eye or something like that. They're discrete pieces of data. So we're concerned with descriptive stats. That's where we go and collect the data, then go present it in some sort of form. Inferential. It's when you make inferences, basically. I can say that word. But that's when we analyse the data, make predictions. That's why we like to collect data. We can make predictions about things. So let's talk a bit about descriptive stats. Provides the summary that we're looking for. We have visual ways, tables, graphs, charts, or we have quantitative. And the calculations we do, univariate data, that's like our mean, median, mode, all those pieces of data that we collect. But bivariate is when we're comparing pieces of data, correlation, drawing lines of best fit, those sort of ideas. So our visual summaries, and probably the first visual summary we ever saw is a frequency table. And we can do that with both numerical and categorical data. Something like this. Okay, we've got a class of 20 students and we ask them, how many pets do you own? And there's our results. The idea of a tally. We use a tally to work it out. So we go along and go, okay, let's see. Oh yeah, there's a 3, a 0, 1, 4, 4. And then we keep putting our tallies in. And of course, when we get to 5, we tend to put a line through it, and then we go. So we have our tally marks. These are the first sort of ideas you would have looked at with stats. And then we say, right, how many tally marks did I get? And then what's the total? We write down the frequency. Contingency tables. Now that's a two-way table. Really good for conditional probability problems. Here's one, speaking of eye colour, but the other piece of data we're collecting is the gender of these people as well. So if we had to work out, according to this data, whether being male and having green eyes are independent. A reminder, we said A and B are independent if the probability of A given B is the same as probability of A. So looking at ours, probability of A given B. Well, probability of male is 82 out of 167 people, 0.4910. But probability of male, if they have green eyes, now as far as we're concerned, we're just looking in the green column, 20 of those 35. Now that's not the same as probability of male, so from this data we would conclude that, being male and having green eyes are not actually independent. How valid that conclusion is, well, that's a different story. Common graphs and charts that we would have seen over the years. Good old line graphs, there's our pet data in a line graph. Column graphs, pie charts or sector graphs, bar charts, dot plots, all these sorts of different types of graphs we've seen over the years. One you may not have seen is this thing called a Pareto chart. And that actually puts two pieces of information on the one graph. Yeah, often used when trying to find defects in production, things like that. Two graphs. It has a frequency histogram, which we arrange in descending order, but then it also has a cumulative frequency polygon. Now, here we go. We're making some shirts and we've discovered some defects in our production and where they were. So the button in some pocket and others, collars, cuffs, sleeves. There is the Pareto chart of that information. So the frequency histogram is being arranged in descending order. It's also how I did my table as well. So button had 23, pocket 16 and so on. But then the cumulative frequency is going up that way. So that's our blue line. We put the frequency on the left hand side we put the cumulative frequency on the right-hand side. So looking at this, if we were trying to work out what to focus on, if we're trying to get rid of as many defects as we can, we might not be able to concentrate on everything. They say, well, logic, okay, look, if I just concentrate on buttons, I'll get a certain amount, but gosh, if I get buttons and pockets, then I'm probably going to get around about 2/3 of the defects out of there by just focusing on those two things. Quantitative summaries. There are measures of central tendency, mode. Okay, the mode, well, we can look at our sample. If we go back to the pets one, the most common one was one pet. It doesn't necessarily have to be unique, the mode. If you could have a bimodal, there might be two things. Trimodal, three things. After that, we tend to say multimodal rather than keeping going. Okay, it's got more than three with the greatest frequency. The median, measure of the middle, much better than the mode, because why should the mode be in the middle? Doesn't necessarily have to be, but the median is exactly the middle. That's what the median is. And remember, depending on the number of scores you have, how you deal with it, if you've got an odd number of scores, then yes, the middle score, when you've got them in order, will be the median. But if you've got an even number of scores, well, then the middle sort of falls halfway between two others. So you've got to average those two to work out what the middle is. So in our example, we had 20 scores. So we've got to average the two middle ones. So it was the average of the 10th and the 11th. So 1.5 pets. Measure of spread then. Range, so maximum minus minimum, but only the numeric data will have a range. You can't say what's the range of the colour of eyes. What's blue minus green? Yellow? I don't know. In our example, the range would be 4 minus 0, 4 pets. So there's a very quick recap on our stats.